Yes, sir. Thank you.
Is it all right up to now? Have you seen the video which we have implemented a simple IoT application in our lab?
Yes, sir. All that is fine, sir.
Yeah, so then what we have done is we implemented this IoT using a simple Bluetooth module, and the specifications of the tanks are like this. The tank which we have taken. So I'll come back to this a little later. So then what we have done is, so this completely wired connections, we try to minimize it by using wireless and through internet. Okay, so we added up one Bluetooth module here. Okay, and then here, and so we and this Bluetooth module can communicate with the mobile. Okay, so then the command which we give it through, as you have seen in the video, so start command or stop command. So based on that, a relay is connected to the motor supply, and on and off command. So the app which we developed using on our own, in which it gives a command to the relay, making on and off of the motor, and could able to implement a simple IoT application for 10 meters range. If it is available similar kind of thing, so then we tried for and then we got succeed. Like the lab in charge of this particular lab in chemical engineering department, he was there as a visiting faculty in one of European country, Portugal. So he want to control this particular plant from that particular state. Okay, so then right then uh, we tried implementing this by replacing Arduino, means Bluetooth module using RPi board. Okay, Raspberry Pi board by using the protocol which is of MQTT protocol implementing, and then implementing simple IoT so that the data can go to that particular person. So through internet, he can monitor his plant wherever he is. So that is what one of the advantages of Internet of Things. Okay, so this we tried of implementing because Internet of Things is not new now. So we started learning of IoT and implementing for our real-time applications. Okay, whatever the resources available here, and this is the second task or the second IoT applications which we did. Is it all right? So possible, I'll try to show you the things. So this is one of the applications by using Internet of Things is what we have seen or done here in the NIT. And nowadays, not only IoT, the device or which we call it as M2M communication. Your device through sensors connects data, and through internet it sends to the database, a server where you can run your machine learning. So now we have to see the field like Internet of Things plus machine learning and big data analysis. This entire thing is a computational complex. So then the recent COVID-19 pandemic, you have seen how it created. Okay, so right. So now let us take this particular video where you have the concepts of this sensor. Okay, sensor, IoT, and machine learning. Okay, entire thing, how it is clubbed and used for a real-time application as. So here, this is what one of the applications. Okay. Okay. So here, this is one of the applications where the combinations of your IoT, machine learning, and big data analysis comes into picture. And really, China has seen the advantage of this. So this is one more application where your each camera collects the data of the face recognition as you have seen in the video. Okay. Okay. And yeah. So this face recognition, this entire data collected and then it is passed on to the server, and where your machine learning algorithm is running for, face identification, and then you can track a COVID patient, the coronavirus patient, how he is moving throughout his places, and you can track how many people he interacted, and you can trace the people who are having this particular disease. This is one more application. And I think all of you have seen these days, this video is also in a viral where in a biomedical application, you are using Internet of Things. This device, this simple robot, which in the entry of your hospital, which scans you and your data is transmitted to the another machine to the doctor. So I think you have seen this. So this is a small video. You can see where you can find the application. So here the sensor is the camera, which collects the data and sends to the next using an internet. Yeah. So this is one more application of Internet of Things. So robot one, robot two, during this critical time, okay, so each device it communicates, and then your data is passed from one place to the another place, and then how doctor, to uses this through telemedicine. So where you can find the applications of IoTs. Okay, so these are the applications of the used cases of Internet of Things, which we find in our real life. Okay, so now another 10-20 minutes, and now let me show you how we implemented this IoT so that you can implement on Arduino architecture especially. Okay, so you can try for similarly on Raspberry Pi or your Jetson Nano board if you are doing your image processing. Okay, so different ways of implementation. Platform can be different. So basically, we have seen 3 to 4 applications, and then I forgot here. One more application I have seen when I visited University of Malaysia in Kuala Lumpur campus, they had an 5G communication lab. So they had a project with Ericsson, and Ericsson decided to save one particular plant, which is of which you can see on the sea bank. Okay, nearer to the sea, so you can see this particular plant, and this plant is dying out. Okay, so then they want to save these plants, so they have planted n number of plants on the coastal area of the sea. And now the task given to the university to monitor the health conditions of those particular plants, a huge area. So then what they have done is each plant, when they are planted, they inserted one moisture sensor there for each plant. And if watering the moisture is means the humid the water is not there, then the pumping has to be takes place. So the humidity and then the entire climate conditions through sensors, they will connect it to the nearby station. Okay, where you are using 5G communication, so they designed their own 5G antenna over there. So these plants through sensors can, these sensors can send information to the nearby communication, which is a 5G antenna. And this 5G antenna collects all the entire information about the plants. And this is going to be transmitted to the university central station through internet. Okay, so this is also one of the application which I have seen there, which they have taken it as a project, and then they are entirely monitoring those plants. So one particular species, they are protecting and using technology of 5G communication plus Internet of Things, using these technologies to uh, uh, to save one particular species. So that is one more application. So these are the used applications for our real-time applications, where you are using Internet of Things. Similarly, you can talk about your smart house. Okay, then your smart grid for electrical people. Okay, so n number of applications. Now you can go through. So now I just give you a demonstration where exactly we implemented one IoT applications here, that is of short range communications only, around 10 meters. So the basic board which we used for this IoT implementation is Arduino Uno, which is of very low cost. You can get it for 250 to 350 rupees based on the availability. And now, so now you know what is the Arduino environment. So it is an hardware, and then the programming environment, and then the implementing one particular application as. So now, if you try to see this robot, okay. So now I have to implement this particular application. Okay. So now you are writing your program, entire program. The sequence is what I explained. So moving forward is what the command you are giving. So this through your mobile app collects an API key. And as a programmer, you are writing your program here in Embedded C. Okay. And then how this device understands your high level languages. So then the sequence, here is like this. Okay. So here in the moment you press a compilation button in your Arduino IDE, it is getting converted into binary language, assembly level languages. So then once it is done compiling, then you are using this button. So here, this is a click button kind of thing. So you can see the environment of Arduino. Okay, so this is what the compilation, and then this is what uploading the assembly language code or the machine level code. So this is what Arduino IDE which you are writing your program, and then the moment you say the upload, so then using, okay, so this particular hardware, so dumps the code into your microcontroller. This entire thing comes with 350 rupees. That's why we prefer Arduino board. Okay, so then now here how this how these two wheels are connected to the microcontroller means you should know about the connections. Right. So this is what the Arduino architecture. So where you have the pins like here if you see uh, okay, here if you see, so pin number here here you have digital IO pins of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and of 13. So these are the digital IO pins, input output pins, which you can connect your IO devices through the microcontroller. And these are the analog input pins. Okay, these are the analog input pins. So here in my objective, I will be focusing on the application which I have chosen. So here a robot has to be designed. So two wheels is what I am connecting. Movement of these wheels is done through motor. Okay, so two motors are what I am trying to connect. So two motors has two wires, and then two means four wires. Four wires have to be connected to this particular board. So then you can connect that using any one of these pins, starting from 2 to 12. Okay, right? So this is in inbuilt. So this is what I'm not trying. So this is what the hardware and here this is what the Bluetooth module. Okay, so this is what the Bluetooth module, which is paired up with your Bluetooth module of your mobile phone, and movement of this can be done through wireless. Okay, so then now here this is one wheel, and here it is another wheel. So these two wheels through motor has to be connected to your microcontroller, which is placed here. Okay, so how it is done? Because the implementing of this, if I want to show you the code, then you have to understand the hardware. Okay, so the movement of the robot can be made in these directions, making forward, backward. So then this motor has to move forward, and this motor has to move forward, and for backward, this is backward. Making right turns, it should it should soft then again and different types. Okay, so then if you want to stop the robot, so this motor should be off, and then this motor should be given a command of off 0 0. Right. So right movement means you can stop this, and then moving this motor forward, it can take a right turn. Okay. So these are the different motions, and this is what the simple working of the DC motor. Okay. Okay, this is available in internet. You can try to see. These are the connections of the motor which are coming out. So one DC motor, when you try to consider, so this is one, this is another wire connection. Similarly, if I take two motors, so then four wide connections has to be connected. So now if I give here plus means 1, which is a 5 volts, okay, which is a 5 volts, and if I give it here on 0, so then it started moving in one direction. So if I give here 0, and then if I give it here, then the motor will be moving anti-clockwise direction. So moving forward means I have to give 1 0, and then moving backward means I have to give 0 1. So similarly, I have two motors, so I have to give for forward motion 1 0 and 1 0 command, and moving backward 0 1, okay, 0 1 and 0 1. And if I want to stop the motor, so then I will be giving a command 0 0 and 0 0. Okay, so this is what the basic hardware connection. Okay, and we use pulse width modulation. So this this can be dealt later. Okay, so then you have inbuilt PWM pins, and now the objective here is This is what your microcontroller. Okay, and here are your two motors, which is used to make the robot forward. Okay, so two wires coming out of this. Okay, so this is one motor. So two wires of this, right? So now we cannot connect the motor directly to the pins of microcontroller. As we know, it draws, the motor for excitation draws huge current. The moment it draws huge current, then the pins of the microcontroller are getting worn out, right? So then we will be using here a bridge circuit, right? The motor driver IC, which is of 293. Okay, 293 ICS. Okay, right? So the port pins which I have shown you on the microcontroller, two pins would be anything from pin number 2 to pin number 13. Okay, connected through this particular driver IC, so that the current, which is a 40 milliamperes current, can be boosted up, so that the excitation of these particular fields happens, and the motors can run. So then we will be using this particular L293, the Texas made IC. Okay, right. So then this is of 16 pin IC. Okay, 16 pin IC. You can take this IC and then you can go ahead, or otherwise in, okay, so so this is the second pin of your microcontroller and third pin of microcontroller. And the connection of this is what, simple programming. I'm trying to demonstrate in 10 to 15 minutes, which is available to me, how to implement a simpler IoT application. And the coding is so easy. And then you can also think of implementing simpler IoT applications in your labs. Okay, so this is what a simple L293. So then just give concentration or focus, right? How it is done and all. Okay, so now here, this is what the L293 is what we need. So this is what the motor connections is, what where we connect here. So 14 pin. This is a simpler connection. Two motors you can connect. You can drive. This particular IC can drive the two motors, okay, which provides buffer and then current amplification. So here now, if you try to see, this is input. From where your microcontroller you are connecting. And this is what the input for this particular motor. So this is 1 and 0 the moment you give here. So 1 and 0 is what when you try to give here. So now you just try to understand the connection of this. This is what a pin called enable, which connected to VCC. Okay, VCC, yeah, this is what the connection is. So the moment you give here VCC, and the moment here on the second pin. So now let us take, second pin. This is what I explained. Second pin and seventh pin, both are connected to the microcontroller pins. Okay, so here you may be connecting here pin number 2 and 3 on your microcontroller. So this 2 and 3 from the microcontroller you will be connecting to driver IC pin number 2 and pin number 7. Okay, so the moment you connected here, so then it is connected to VCC 5 volts. The moment it is connected to 5 volts, this is a buffer cum amplifier. So whatever the command you give here on pin number 7 and then pin number 2. So now if I am giving here 1 and then 0, so then this 1 is passed through because this is a buffer. So 1 is connected here. So here it is connected 1. So here you have a connection 1. Right, and similarly this is connected to 0. So anyhow this is enabled, this is connected to 0, then motor will be moving or turning in one direction. And if I give here in a reverse direction like 1 here and 0, then motor rotates in other direction. Okay, just a second. Right, so the motor rotates in the other direction. But this is a simpler connection. These steps, I know why I'm explaining. I will try to show you the code which we implemented the same video which I have shown. Right. So this is what simple motor connections which we did through L293D IC, and this is available in Amazon, 200 rupees motor driver. So you can connect this, right? And then after this, so this is what the simpler connection, okay, so which we make through L293 driver, so you can easily identify. So this is what the microcontroller, this is what the L293D through which the two motors are getting connected, right? And now the next one is the Bluetooth module. Okay, so the Bluetooth module has 4 connections, right? So 2 power supply connections and 1 transmit and receive. Okay, 1 transmit and receive, and this transmit and receive you can connect it to the microcontroller pins here, as we have seen. Yeah, so the microcontroller pin number 2 and pin number 3 here, if you try to see here, 0 pin and the first pin are transmit and receive. Okay, transmit and receive. So the transmitted from the Bluetooth module, so TX of this should be connected to the receiver of this, and the transmitted part from the microcontroller should be connected to the receiver of the Bluetooth module. This is the simpler connection. So this is how we connected Bluetooth module to, right? So now if you let us try to see. So this is what this simpler connection. And now if you try to take the app, so the next step is to develop a mobile app, right? So this mobile app you can try to develop by using, okay, by using MIT App Inventor. Okay, so MIT App Inventor. So you can create your own apps. So a number of tutorials are available. So you can make your own app, right? And then we designed 2 apps here, for one for robot and another one for the plant which I have shown. So that is the other way of implementing PID complete PID controllers. So this is what the app which we designed. So here you have Bluetooth. So then this Bluetooth, you can, by pressing this button, you can pair up. It scans, your mobile scans nearby Bluetooth modules, and once it is connected, then it can say like it is paired. So here, once the pairing is done, okay, once the pairing is done, then you have a speech, speech kind of module. So where you can give your speech signal like forward or backward. Okay, I have, as I gave you demo in the beginning.
Do you have any speech? No speech kind of module. You can give your speech signal like forward or backward. Okay, I have, as I gave you demo in the beginning.
Forward.
Forward.
It recognizes. Backward.
Backward.
Right.
Right.
Yeah. So this this uses, this mobile app uses internet of your mobile and connects to the Google server. Okay, so this is what the simpler implementation. This is what the code. Okay, this is what the code for implementing this. So here I have 2 motors as I explained. So pin 5 and 6. Okay, so this pin 5 and 6 are connected to the left motor, and 7 and 8 are connected to the right motor. Okay, so here initial, in the beginning you have to do initialization. So you are making all the pins to the output pins on which you can send the command. Okay, so now you are checking on the serial module, okay, serial pin of your microcontroller. If it is available, that means it is any command by any other, this is a valid command or not, you give a delay and again you check. So once you find a command or API key kind of thing on your receiver of your the 0 and first bin of your microcontroller, which I have shown you here. Okay, so here, okay, so the microcontroller, when you